Hello students, in this lecture of Unit-3, we'll discuss some examples related to fuzzy relations and some examples related to composition of fuzzy relations. So let us start the lecture. Here we are considering an example where two fuzzy sets are given to us. They are fuzzy set A and fuzzy set B. These two fuzzy sets are defined on two different universes of discourse. In first universe of discourse, we are considering that there are three elements on which fuzzy set A is defined with the membership values 0.3, 0.7 and 1.0. Similarly, another fuzzy set which is defined on another fuzzy set B which is defined in another universe of discourse having two elements, they are y1 and y2, and their membership values capped as 0.4 and 0.9. Now here our objective is we want to find out a relationship with fuzzy set A and fuzzy set B. Now here students, I would like to recall you the very important basic concept of the fuzzy relation, and according to this concept all the element of one universe of discourse are related to all the elements of another universe of discourse up to some constant, or they are not related at all. So here what we want to make some sense here, that all the element, once we are making a connection of all element of set A with all element of set B, here it simply means we want some kind of Cartesian product of set A with set B. So here when we are making the Cartesian product, the product will have the ordered pair of x1 y1, x1 y2, x2 y1, x2 y2, x3 y1 and x3 y2. These are the all possible ordered pair which are possible by making the Cartesian product of these two fuzzy sets. So now here, see here, say for example we are making an ordered pair of x1 y1. In that type of scenario, this ordered pair will have some membership value. Rather, we can say that here what is happening, we are trying to make a relationship between x1 and y1, and that relationship will have some membership value, and which will be considered the minimum of the membership value of x1 or the value of membership value of y1. So the association of x1 y1 will have the minimum membership value of 0.3 or 0.4. Here we can say the minimum value will be 0.3. Similarly, once we will be getting association between element x1 with element y2, so the membership value will be again 0.3. Reason is that because x1 is having membership value 0.3 and y2 is having membership value 0.9, and once we make the association of these two elements with the help of a relation, so in that case the membership value of the link x1 y1 will be the minimum of these two, and it will be again 0.3. So here you can see what we are doing here. For the fuzzy relations set R, we are finding out the membership value of these ordered pair x1 y1, x1 y2, x2 y1, x2 y2, x3 y1 and x3 y2 with the help of the minimum of their membership values. So once we are making the Cartesian product of two fuzzy sets, rather we can say we are making a relationship between the two fuzzy sets, so we get the membership value with the help of the minimum function. So here what we are doing, we are finding the minimum from these two values, mu a x1 or mu b y1. Out of these, the minimum value would be considered as the membership value of the association of x1 y1. So by this way we are getting here 0.3. Now see here, when we are taking a ordered pair of x1 y1, the minimum is 0.3, so here we are writing 0.3. Now take x1 y2, so when we are taking x1 y2, the minimum is again 0.3, we are writing here 0.3. Now ordered pair is x2 y1, so x2 y1, the minimum value is 0.4, 0.4 is mentioned here. Now the ordered pair is x2 y2, so x2 y2 is these two are there. So minimum of the membership value is 0.7. 0.7 is mentioned here. Now ordered pair is x3 y1. The minimum value is 0.4. 0.4 is mentioned here. x3 y2. x3 y2 is this association, and the minimum membership value is 0.9. We are mentioning it here. So that's why it's a style to make a fuzzy relationship over to fuzzy sets. Now we are coming to the next example, and in the next example, let us see the next example. Say, next example is related to the composition of the fuzzy relations. Here in this example, two fuzzy relations are given to us, and these two fuzzy relations are relation R and relation S. Fuzzy relation R is working on two fuzzy sets, and they are set X and set Y, whereas the fuzzy set Y is common in these two relations. So S is the fuzzy relation which is working on fuzzy set Y and fuzzy set Z. So that is the condition, that is the condition that once we make the composition of two fuzzy relation, so they must have a common universe of discourse. Until unless we are not having a common universe of discourse, we won't be able to establish a relationship from first universe of discourse to the last universe of discourse, right? So it's a way to represent the composition of the relations. So this composition can be done with the by the help of two methodologies. One is the max-min composition, another is the max product composition. So one is the max-min composition, another is the max product composition. So now we are making the fuzzy relation, and we are saying the composition as the T composition. So fuzzy relation T will be achieved by doing the composition of fuzzy set R with the fuzzy set S. So here what we are doing the max-min composition. So as we want to make a relationship between x1 and between the element of set X with the element of set Z. So what is our objective here in this example? We want to establish a relationship between the element of universe of discourse X with the element of universe of discourse Z. We want a relationship between x1 x2 with z1 z2 z3. So source is given to us, destination is given to us. So there will be an ordered pair x1 z1 x1 z2 x1 z3. Similarly, there will be some another ordered pair x2 z1 x2 z2 x2 z3 also. So these relationship has to be established now. So see friends, here source is fixed here, destination is also fixed. Say for example, we want an association between x1 and z1. So x1 is fixed and z1 is fixed, but there are two ways. Either we can go to y1 and then come to z1, or we can go to y2 then come on z1. So in these two ways, out of these two ways, we will find out the best way, and best way means we will take the maximum of their value, and in making one root final we will keep the minimum, right? As I already discussed you with a very suitable example. Say for example, I just want to go from Ghaziabad to Lucknow, and there are two ways. One is via Aligarh and another is via Agra. Say for example, and we are rating the intermediary node from Ghaziabad to Aligarh. I am giving it's a membership value 1. 1 is indicating that the path is very wonderful, it's beautiful, there is no pothole, there is no congestion, road condition is fantastic. So I am giving it the membership value 1. So from Ghaziabad to Aligarh, say for example, membership value is 1, but from Aligarh to Lucknow, road condition is not good, it is poor, so I am giving it 0.4. So the overall condition will be considered from Ghaziabad to Lucknow via Aligarh will be 0.4. So minimum value will be considered there. Now take another example, like from Ghaziabad to Agra. Say for example, condition is good but not the fantastic, so I am giving it the membership value 0.7, and from Agra to Lucknow it is 0.8. So we are taking with the minus with the minimum value of the complete path. So if I am going from Ghaziabad to Lucknow via Agra, So the minimum value will be 0.7. Now there are two paths, and these two paths are having their own minimum values. So out of their own minimum values, we will select the path which is having the maximum value. So here we have seen that from Ghaziabad to Lucknow via Agra, it is having its own minimum value, which is 0.7, and the minimum value of the path from Ghaziabad to Lucknow from Aligarh, it is zero point 0.4. So we will choose the maximum value. So it means we will prefer a path from Ghaziabad to Lucknow via Agra. So in the same way, I am just coming here again. X1 is fixed, it is the source. Z1 is fixed, it is the destination. There are two paths. We can come from X1 to Z1 via Y1 or via Y3. So if via Y1 I am coming, so X1 to Y1 its membership is 0.6, and from Y1 to Z1 its membership is 1. So we will take the minimum one. So its value will be, minimum value will be 0.6. So keep remember this thing, that from first way the cost is coming to 0.6. Now via Y2, if I am coming from Y2, its the minimum value is 0.3, and from Y2 to Z1 is its value is 0.8. So we'll take the minimum one. The minimum value is 0.3. Out of these two paths, we will choose the maximum one, and the maximum will be 0.6. So that's why 0.6 we are mentioning it here. You can see here what we are doing. We are taking the max min composition, and max min composition says that we will first of all we will choose the minimum of x1y and y1 z1. Out of these two subpaths, we will choose the minimum one, and from the another path which is being halted by intermediary by y2, we will choose the minimum out of these, and out of their own minimums we will get the maximum value. So from the first way, if we are coming from y1, its value is coming to 0.6, and if we are choosing the intermediary part y2, its value is coming to 0.3, and we are taking the maximum out of these, and its value is 0.6. See here once again, x1 to y1 its cost is 0.6, y1 to z1 its cost is 1. We will keep the minimum one. Minimum one is 0.6. From first way its minimum value is 0.6. Now another is x1 to y2 its cost is 0.3, and y2 to z1 its cost is 0.8. We will take the minimum, that will be 0.3. So out of 0.6 and 0.3, the maximum value will be 0.6. By the same way, we will calculate the degree of association in each ordered pair of element of x with the element of z, and by this way we are finding out the max min composition, right? Now there is one another style to do the same job, that is the finding the composition of the relation with the help of the max product rule. And according to the max product rule, we are not writing here O, we are simply mentioning here dot. So what we are doing, we are finding the max product rule. Here the max product rule says that we will do the multiplication of the membership values of the intermediary path of one route, and we will do the multiplication of the membership values of the intermediary path of the another route. So out of these values, we will choose the maximum value. Out of these values, we will choose the maximum value. So here, what was the scenario? This was the cost from Ghaziabad to Aligarh. Dot cost of Aligarh to Lucknow. So this value comes out. Another path was Ghaziabad to Agra. Its cost dot Agra to Lucknow, its cost. So we will multiply these values, and once the value will come out, so here the value is coming 0.6 and this value is 0.24, and we'll choose the max out of these, and the value is 0.6, right? So by this way we can calculate the degree of association of all the ordered pair of element of fuzzy set which is available in universe of discourse of X with the element of universe of discourse Z. So by this way we have seen the composition of different fuzzy relations. So now let's all come on the very realistic example which gives us a very good information related to the fuzzy relation. Friends, again I am just repeating my statement, and this is a very important statement related to the fuzzy relation. And this statement says that all the elements of one universe of discourse, they are related to all the other elements of another universe of discourse, or they may not be associated, they may not be connected. If they are not connected, then at that time in the Cartesian table, their membership value will be maintained as 0. Otherwise, they all will have some membership value. If they are strongly connected, if there is a complete membership value, then we can have the membership value as 1. So see here, we have making two different universe of discourse. There are two different universe of discourse. One is the x1, another is x2. There are two different universe of discourse, right? One is related to the diseases and another is related to symptoms. So in x1 there are three diseases. One is typhoid, another is viral fever, and the third one is the common cold. And the another fuzzy set, which is the set of symptoms. Here we are having three different symptoms, that is running nose, high temperature, and shivering. So see here we are having two fuzzy sets, and once we are interested to make a relationship between these two fuzzy sets, and according to that relation, that would be named as the binary fuzzy relation. It will have the connection of all element of set A with the all element of set B, as the universal statement is there, that all the element of one universe of discourse will be connected with the all the element of the another universe. So right here, with I'm seeing that fuzzy relation R can be represented here. This is one fuzzy set. It is another fuzzy set for typhoid. Running nose, association of running nose is 0.1. High temperature is 0.9. Shivering is 0.8. For viral fever, this information, this data, this membership value has been taken by the help of some of the expert by their own opinion. See here what we are doing, we are making a sort of the association between the different diseases and the symptoms on the basis of the expertise level of some doctors or the medical paramedical staff. So on their opinion, we are trying to establish a fuzzy relationship between these two universes of discourse. And in the case of viral fever, we are making a membership value that is 0.2 with the running nose, and 0.9 with the high temperature, and 0.7 with the shivering condition. For common cold, common cold disease, the symptoms of running nose is 0.9 and 0.4 with high temperature, and 0.6 is shivering. So it's a very beautiful example which depicts us the real-time scenario of establishing a fuzzy relationship between two different fuzzy universes of discourse, right? So now let's come on the another example. See here, one another example is there which we are going to understand. Here we are asked that there is a DC motor. There is a DC motor, and the membership value of the series resistance and the armature current and the speed are given. So here the membership values, the membership function of the series resistance of the DC motor, the armature current, the current which is flowing in the DC motor, that is also given, and the speed of the motor, it is also given. So these three are given with the three different fuzzy signs. So here what with the expertise level of some of the electricians, that information has been recorded, and accordingly different fuzzy sets have been prepared. So there is a fuzzy set, that is R fuzzy set, RSE, series resistance, that is series resistance. This one fuzzy set has been there for 30 ohm resistance. Somebody is saying that it is this value will be 0.4, membership value will be 0.4, right? For just a minute. Right. So, and the fuzzy relation, the fuzzy set, which is the IA, which is the related to the current, armature current, it is given to us that suppose 20 ampere, for 20 ampere membership value is 0.2, for 40 ampere membership value is 0.3, similarly like that. And here this is N is the number of turns per second, so it is RPM, it is related to the RPM. So For 500 membership value is 0.35, for 1000 membership value is 0.67, for 1500 its value is like this one, for 1800 membership value is like this. So here we are having three fuzzy sets which we have established with the help of the expertise available with us in terms of some electricians, those who are capturing some information and giving us their views in terms of their information in terms of series current, in terms of current, armature current, and in terms of the RPM of the motor. And now we are asked to make a relationship between the series resistance and the speed of the motor and the number of rotations, RPM of the motor. So our objective is to find a relationship between the resistance of the motor and the number of rotations of the motor. So we are not making any kind of the formula, electrical formula. So what we are doing, we are trying to make a relationship between the series resistance and the number of rotations of the DC motor on the basis of the fuzzy information which we receive from some expertise. So right here, so what we see here, first of all, we can make a Cartesian product of RE to IA. So by doing so, if anyhow I am able to make a Cartesian product of these two fuzzy sets, so that simply will represent a relation of these two fuzzy sets. And once I am able to establish a relation between these two fuzzy sets, so that relation is represented by R. And suppose I am able to maintain a relationship from current with the speed of the motor, so that relationship is represented by S. So now here, see what is happening. We are having one fuzzy relationship which works on two fuzzy sets. So here we are having a fuzzy graph from R to I, and then we are having a fuzzy graph from I to N. Our objective is to make a relationship between the series resistance and the speed of the motor. So that can only be achieved with the help of the composition operation of the different fuzzy relations. So here our objective is to find out the composition of two fuzzy relations. So first of all, fuzzy sets are given to us. Our objective is to find out the two fuzzy relations, one from RSE to IA, another is from IA to N. So these two fuzzy relation is our first prime objective. Once they have been achieved, these two fuzzy relations have been achieved, then our further objective is to find the composition of these two binary relations, and they will establish a relationship between the series resistance and the speed of the motor. So here, see here how I am making the Cartesian product of the first two fuzzy set. Here for 30 ohm resistance, I am making a relationship. I am making a relationship of 30 ohm resistance with 20, 40, 60, 80, 100 and 120 ampere of current. So fuzzy relationship, as I already told you, that to make the Cartesian product we will take the minimum value of the elements of the ordered pair. So say for example I am making an ordered pair of 30-20. For these ordered pair, the membership value will be the minimum of out of these two, that will be 0.2. So for 30-20, the minimum value is 0.2. For 30-40, the minimum value is 0.3. Similarly for 30-120, the minimum value is 0.2. So here the 0.2 is mentioned here. In the same way, we will populate the Cartesian product of first two fuzzy sets, and that will establish a relationship between these two fuzzy sets. Further, what I am doing here, I am trying to establish a relationship between, I am trying to make a Cartesian product of second and third fuzzy set, and that again will be based on the concept of finding the minimum membership value of the element in the ordered pair. So here I am making a relationship between the 20 ampere current with 500 RPM speed. So 20 ampere current, I am writing it here, 20 ampere, 40 ampere, 60, 80, 100 and 120, these are the current, and 500, 1000, 1500 and 1800, they are the speed of the motor in RPM. So I am making a relationship between the 20 ampere current with 500 RPM. So there is what should be the membership value? Membership value would be the minimum out of these. So minimum is 0.2. Then I'm making a relationship between the 20 ampere current with 1000 rpm. So the membership value will be the minimum out of these two, and the minimum value is 0.2 again. So here you are saying the 0.2. So here again the minimum value will be 0.2. Here I am making a relationship of 1800 rpm with 20 ampere with 1800 rpm. That will be minimum of out of these two, and that is 0.2. By this way, I am making a Cartesian product of two domains. One is I, ampere current, and another domain is RPM. So once that once that Cartesian product has been established, so we can say that we have established a relationship, fuzzy relationship among these two fuzzy sets. And the final objective is we have to make a relationship of all the elements of first fuzzy set with all the element of the last fuzzy set. So here we are applying here the max min composition. Here what we are doing, we are applying ROS. So ROS will be the max min composition. What we will do, I am just trying to make a relationship between between 30 ohm resistance to 500 rpm. So that connection can be with the help of 20 ampere, with the help of 40 ampere, with the help of 60 ampere, with the help of 80, and then 100, then 120. Out of these different paths, from all the different paths, we will select the minimum of the paths. And once all the path values have been find out, we will collect the maximum of them, and that's why we are getting the value here. See here how it is happening. For 30, if I am coming to 20, its value is 0.2, and from 20 to 500, its value is 0.2. So the minimum will become 0.2, right? If it is going to 0.30 and then it is 0.3, the minimum is 0.3. If it is coming to 0.4, 0.4, and from 62 it is 0.35. Now the minimum value is 0.35. Then 0.4, 0.35, the minimum value is 0.35. Then 0.4, and then for 100 to 500 it is 0.35. Then 0.2, and 0.2 to 500, its value is 0.2. So out of these different values, we will choose the maximum one. So maximum will is 0.35. That is why it is coming here. In the same way, we will populate all the membership value of the ordered pair of R, SE with N. And once that information has been found, so we are having a fair enough idea which relates us about the series resistance, and finally finding the speed of the motor. So that's all about this lecture. So now we are just near about to complete the unit 3. One topic is left behind, and in the next lecture we will complete that topic, and the topic is the membership function, and then your unit 3 will be finished. So thank you for this lecture. See you soon.